Intervals of increasing, decreasing, and constant. On this next one, right below it, I'm going to write local extrema. Local extrema are broken into two different kinds. There's a local minimum.
No, I just. So extreme.
I know.
Minimum extreme.
Local means just in one little area, okay, as opposed to absolute. Yeah. Absolute. There's a extrema. There are two different types. There's absolute minimum and an absolute max. And the last little thing here, we're going to write zeros, roots, and solutions. The first little window here, that's going to be the one that has the most writing in it. So intervals of increasing, decreasing, and constant. So are you guys ready to open it up and fill out inside?
Yeah.
Okay. So we are going to write inside now. So we're going to write how to determine intervals of increasing, decreasing, or constant. By the way, when I say interval, what am I talking about? X values or Y values? Or just X? Yes.
Yeah, I thought I said wrong.
You too.
No.
So what was that Y called?
So when we are doing range, that is an interval of Y, but usually when we talk about an interval, we only care about X. Yeah, because we think of things more horizontally. When we draw a number line, we draw it horizontally. So X is the first piece of the address, right? And then comes the Y. So when we talk about an interval, we don't really care about anything except the X, because once we know the X, we know where to find the Y. You just look up, right?
Yeah.
Or use a formula. So to determine the interval, read the graph from left to right. And what that means is if I pick on the left x to equal a and on the right x to equal b, all right, what is the relationship between a and b always going to be? What are my x values doing?
A is left, B is right.
Okay, so that means a is less than b. If x is -1, the next value is going to have to be bigger than it, right? The next x value has to be something over here, bigger, okay? So because I'm reading, so a, the first x value will always be smaller than the second x value.
If it's 2, it needs to be bigger than 2.
Yeah, exactly. All right. So we're going to read the graph from left to right, so the x values will always be increasing. Does that make sense? So we're going to know that the graph is increasing. It's increasing if f of a is less than f of b. What does f of a and f of b represent? F at a is a y value. F at b is a y value.
Oh, okay.
Oh, so we're talking about Y now?
Mm-hmm.
Yeah, 'cause like,
So when you see f at a, that's the function value at a, right? So that's the y value. So it's increasing if the y values are also increasing. Does that make sense?
Yeah.
So I'm going to highlight. So it's increasing from here to here. This
is the
is increasing. Why is it increasing there? What's happening to the y values?
I'm not answering.
They're going up, right? F at 1 is smaller than the function at like 1.5. At 1.5, it's about 1, right?
Yeah.
Which, so as x gets bigger, y is also getting bigger.
When it's going to 3, isn't it the y where we're going down?
Since we're reading this way, right? The y values are getting bigger and bigger and bigger.
Yeah.
Here it stops. That's where I've stopped highlighting. Because right here it's stopped increasing, right? The next y value is not going to be bigger. The next y value is going to be smaller. So what's the next thing that we're going to do is decreasing. So it's decreasing if what? F of A is bigger than F of B. So you're right. You said F of B is less than F of A. Yes, that's correct. All right, so decreasing. And then constant.
Isn't like a straight line?
A straight horizontal line, yes. Okay, so when is it going to be constant? Yeah. All right, so there's intervals of decreasing on here too, right? It's decreasing here and it's decreasing here. All right, so what intervals is this graph increasing on?
1 and 2.
From, yes, it increases from 1 to 2.
Yeah.
And
3 and 5. No, the 3 and 4 points.
I drew an arrow at the end, so if I draw a little arrow at the end, what does that mean? Infinity, yeah. Right. So here it's increasing. Okay, here it's also increasing. So it increases on 1 to 2 and 3 to infinity.
It decreases from negative infinity to 1.
Okay, it decreases from negative infinity to 1.
And 2 to 3. No. 3 to 2.
2 to 3 is correct. Okay. So increasing on the orange, decreasing on the blue. And is it constant any place?
No.
No. Not here, no. It would be a horizontal line if it were constant.
But then, like,
well, because x is going to get bigger, and as x gets bigger, the y is going to have a value. It just doesn't fit on this page. So this doesn't go completely straight up. This goes this direction, right? So it's going to continue to kind of go this direction. So the y's are going to get bigger, but the x's are also slowly getting bigger. So eventually every x will be covered. Okay? So it doesn't stop here. It just keeps going. So 6 is going to have a y value. It's just not going to be on this page. Okay? Okay. So that is intervals of increasing, decreasing, constant. All right. Now let's talk about the local extrema, a local minimum and a local maximum. So a local min, not the lowest point on the graph, but it is going to be where it goes from decreasing to increasing. A local min occurs, and by the way, the local min will be the y value. Okay, so the minimum is the y value. A local min is the y value where the graph changes from decreasing right? So the local minimum is the y value where the graph changes from decreasing to increasing. And what is the local max then?
From increasing.
Okay, so here we have two local minimum and one local maximum. Do you guys agree?
Yes, ma'am.
Okay.
So local maximum is the opposite of local minimum.
Yep.
So the local minimum here is going to be 1.
It's at 1.
Yes, at 1.
So the local min.
Infinity to 1.
Nope. The local min of 0 at x equals 1. So there's a local minimum of 0 when x is 1, yes.
For local max, what does it say after change? Change from increase to decrease.
Changes from increase to decrease. Yeah, sorry, got a little smudged. Is infinity a number?
No.
No, so infinity can never be a minimum or a maximum. Okay? So there's another local minimum. What's this local minimum value?
1 at 1, 3.
Yep, the local minimum value of 1 occurring at 3.
Okay, and then local maximum is 2 and 2.
Mm-hmm.
That
So there's a local maximum of 2 at x equals 2.
Yeah.
Okay.
And then
So what do you guys think then is an absolute extrema, an absolute minimum, and an absolute maximum? What do you think that's going to mean?
there's that basically the lowest.
The highest or lowest points on the graph, yes.
I was about to say that. So it's going to be 1 and infinite. Like 1 is lowest and highest and infinite.
Again, it's a y value. Not infinity. Infinity is not a number. Okay. So for the graph that we have here, do we have an absolute maximum?
No. We don't.
No, the y value continues to get bigger and bigger and bigger. So there is no,
Wait, but we have lowest.
yes,
Lowest is 1.
there is no absolute,
No call stupid. Oh.
No,
so
it's
there's
not.
no absolute maximum. There's no absolute maximum, but the absolute minimum is 0.
Need the- I was testing them.
Yeah, no, it is. Can you just be quiet, please?
The absolute minimum is 0. Okay? So there's no absolute maximum. A graph that looks like this is never going to have an absolute minimum or maximum. Does that make sense? And a graph that maybe is sort of a curvy W shape, this point and this point, if they're the same, they can both be, I mean, it's the same y value, right? But the minimum can occur twice. The maximum could occur at 2 different places or 3 different places. Does that make sense? So it's the same minimum, it just appears 2 different places. Does that make sense?
Yes.
But there's only one y value because this y value is the same as this y value. Does that make sense? 0, root, or solution. So zeros, roots, and solutions, it's all the same thing, all the same way of asking for the x-intercept. So zeros, roots, solutions, these, we use them in different contexts, okay? But what it's asking for is the x-intercept, not the y-intercept.